My name is Jackson Berger,
I'm Will.
and this is our DCDM commercial project. There's three main things we're going to be covering today in our portion of the project, and that is, the first thing would be the generator sizing and its cut sheets. Secondly would be the ATS sizing and its cut sheets, and third would be the Minnesota energy calculation of the inside and the exterior of the building. This is a snapshot of the Cummins Power Suite software that we use to size our generator. The snapshot shows all the loads on the left there that will be on this generator, which include the lighting panel, the receptacle panel, the air handling unit, two condensing units, one for now and one for future expansion, and also two boiler pumps. And it also shows right below there that all of these loads will be on the same step, starting at relatively the same time. This is a snapshot of the lighting panel and how we entered it into the software to size it. We had to, there were a few things we had to enter in. One was the running KVA, which you can see was 67, and also that it was a 208 three-phase load. And in comparison to that, this is what we had to enter in for the boiler pump load. This one was similar, but as you can see, we had to enter in the horsepower for this one, which was 2, and then also, once again, it was the 208 three-phase. And on this one, you had to enter in the motor type, which we decided to use the standard NEMA design B, C, or D. And once you filled out all the information necessary for all the loads, there's a calculate button, and you just hit that, and it'll come up with what size of generator you need. It's pretty slick how it works. But as you can see, it came out to be a 230D FAB model that has a site-rated max starting kilowatt of 255. And here's our cut sheet for our generator. It is a diesel generator set. It's a QSL9-3G/G5 engine. And here's our the Minnesota energy calculation we had to do also. It was we used the ComCheck 3.9 software on this. And personally, I'm just doing the outside. My partner in a second will explain the inside. For this, it was fairly simple. We just used two different type of fixtures. The first of which was a 400 watt metal halide single lamp that we used for the parking lot lights that were mounted at 30 feet. And secondly, we used the 150 watt metal halide for the a wall pack for the exterior of the building, just for lighting around the building. And also, once you enter those in, you pick the type of fixtures you need, and it will tell you down at the bottom of the right-hand corner there whether you're compliant with the Minnesota Energy Code. And for the exterior, it turned out we were 41% above the Energy Code. So I will pass it on to my partner, Will.
Thank you. So I'm going to start talking about the automatic transfer sizing. Our transfer sizing is all based off of the main panel, which Jackson was talking about. So we have 500, it's rated at 500 amps for the overcurrent protection device. We ran two sets of 250 kc metal cable. We also had to do a burial of that, and we ran that in 3-inch PVC pipe. It was two separate runs due to the size of the cable needed for 500 amps. And then also with our project, we want to allow for 10% growth, and also following the NFPA guideline 70. And then also, this is just explaining the transfer switch product itself. So it's going to be UL listed, and then also going to be ready for the transfer switch. Obviously, is going to be if to kick the backup generator in if there's any sort of power failure. And then we'll go on to our Minnesota lighting, our energy code. I worked on the interior lighting. So we had to follow the 98.1 2004 standard. Mostly, this is just a breakdown of all of our different lighting. So it's got all the different rooms listed. I'm not gonna go through every single room, but basically it's got the different rooms listed. We have to put in the actual area, the square footage, and then it'll calculate whether we're compliant with the code. For most of our lighting, we use either compact fluorescent bulbs or standard fluorescent bulbs with electronic ballast. They're a little bit more energy efficient as well. And then based on our calculation, we're 54% above compliance. And this is just a little bit better show of breaking down what we did to calculate our area, the different rooms, and how we got to the final outcome. That's pretty much it. Any questions or anything?
Thank you.